4.5 Writing Inequalities for Word Problems. It's been a while, that's for sure. I've been out of country, you've been at fair, and it sounds like you haven't been doing your homework. So you better start doing your homework. Anyway, yeah, word problems. Let's see how it's done. On page 139 at the top, we see writing inequalities for word problems. Assign a variable to represent unknowns. We know that. We've done that before. Recognize proper inequality. That's going to be based on language. Write an inequality that represents the problem. No duh. That's what we're trying to do. That just means construct the sentence. Solve the inequality. Solve means get the variable by itself. That's always what solve means. Write it down in your notes again if you didn't know that off the top of your head. And answer the original question, go back to what the question was asking for, and give the correct response. Alright, let's knock out these practice problems. 4.5a. The Frey family wishes to pay at most $151,000 for a lot and house. What is the most they can pay to build a house if the lot cost $32,000? Okay, we just want to break our sentence up into chunks. That's all we want to do. It's all what we always want to do. But first of all, let's figure out our variables. What are our variables? What are our unknowns? And even what are our knowns? Because those are also useful. So it's always good to just start with what's unknown and what's known. So what do we know? The most they want to pay is $151,000. So if the most they want to pay is $151,000, all right? That's fine. Just write down sentences. Just write down stuff you know. That's the best way to do it. What else do we know about pay? Well, let's not jump ahead of ourselves. What else is unknown? We don't know the cost of the house. We don't know the cost of the lot. Let's call H the cost of house and L the cost of lot. Perfect. All right. Let's see what else we can figure out from this sentence. It says how much can they build for the house if the lot cost $32,000? So from that, we know that the lot actually cost $32,000. All right, that's helpful. What else do we know? They want to pay at most $151,000 for the lot and house. So we know that this $151,000 is the same as the cost of the house plus the cost of the lot. And actually, that's incorrect because it doesn't say equal to, it says at most. At most. So if something is at most $151,000, it's either going to be equal to $151,000 or it's going to be less than $151,000. Let's think about the right way to draw this little arrow. Or let's just think about another way to phrase this question. The house plus the lot must be less than or equal to $151,000. So that's an easier way to put it. The house plus the lot must be less than or equal to $151,000. Beautiful. Which means this arrow over here would point this way. Anyway, we're just looking at our sentences and just converting the English into math. Normally we put equal signs, but in this case it used different language. It didn't say equals, it says at most, which is an indication of something other than equals. All right, so we got this. Now we do know that L equals what? 32,000, so we can do a substitution. Always do substitutions with parentheses, that's for sure. All right, great. And let's look back on what the top of page 139 says. It says assign variables. All right, we did that right here. We assigned our variables. We recognize the proper inequality symbol. We did that. Step 3, write the inequality. We did that. For solve, what does solve mean? If you haven't written it down, write it down. Solve means get the variable by itself. We only have one variable. We are good to solve. How do we get H by itself? It's being added by 32,000, so we subtract 32,000 on each side, and that's going to give us a number. H, what does H represent? The cost of the house, so we can say the cost of the house is less than or equal to something. I cheated. 119,000. All right. All we did was follow the steps at the page of 139. Copy that chart at the top of page 139, because that is literally what we do for not only inequality problems, but regular problems too. It's a good guide to have. Alright, let's jump right into the homework problems. Alright, once again, I've merged the lesson video and the homework problems into one. So let's start with the evens. Let's start with number 2. 5 less than twice a number is equal to or greater than 21. Alright, so I just want to give you as many strategies as possible. It may be confusing to give you a lot of strategies, but if you don't get one, it might be useful to see the other. So let's just start by rewriting the problem. Alright, that's the problem from the problem. So 5 less than twice a number is equal to or greater than 21. So let's just start making some conversions with some stuff we know. So let's find the is. Is. We know that is equal to, right? But it's not just equal, is equal to or greater than. Alright, so right here in the green, we know that we're going to replace that English with this. Is equal to or greater than. Or another way of saying that is greater than or equal to. Alright, greater than what? 21. So we can convert this right here. It's already in math, so we just rewrite it as math. Alright, great. We've got the whole right side of the problem already taken care of. 5 less than twice a number. Alright, now remember, whenever we see this less than, we got to think about it in the right way. So let's be patient. So 5 less than, if I say 5 less than 6, that equals 1. So did I do 5 minus 6 or did I do 6 minus 1? I did 6 minus 1. So remember, when we see that less than, we're kind of flipping the two portions around. So we're really saying twice a number minus 5. So let's just go ahead and rewrite that in English right now. Alright, all we did here was just turn English into a different form of English. We do that all the time in our life. All the time in our life we do that. See? I did it just then. Just then I did it. All I'm doing is flipping it around. Alright, great. So twice a number, but what is the number? A number, that's just a variable. We don't know what it is. So we can convert that to an x. And what do you think twice means? Twice is our coefficient. Minus, we know what minus means. Minus means subtract. 5 is 5. And rewrite everything else. So now we got 2x minus 5 is less than or equal to 21. And then what do we want to do? We want to find the number, which means solve for that number. What was that number? That number was our x. So we want to solve for x by getting x by itself. So add 5. That gives us 2x greater than or equal to 26. And then divide by 2. We see that x is greater than or equal to 13. All right. Just turning English into math. English into math. Patience, patience, patience. Writing it down. Doing it the long way saves you time because you're focused, you're organized, you recognize what you're doing, and you're able to look back on it. And it makes you better in the long run. Don't be scared to write stuff down. Alright, question 8. Brett cuts grass for $30 per yard. How many yards would he need to cut in order to earn at least $200? Funny story, when I first read this problem, I thought when they said yard, they meant like a yardstick, like 3 feet. So, ha ha ha. Anyway, alright, let's do what we did the last problem. Just do one thing at a time. Brett cuts grass for $30 per yard. That's just a fancy way of saying for every yard he cuts, it makes $30. I don't know which ones are. Anyway, not really it's pretty simple right here. We don't really need to convert that. How many yards would he need to cut in a day to earn at least $200? I take it back. We do need to do something with this first sentence. So what's the thing? What are we trying to find out? What's the unknown? The unknown is how many yards he needs to cut in a day. Or just simplify it, yards. Yards are the unknown. Let's just do y equals number of yards. Alright? Now this is something we talked about before. We got quantity and we got value. Value is the price times the amount, or quantity, equals value. Now we want to know what the value of each yard is. The value of each yard is $30. Or the price of each yard is $30. So we got $30 is the price of each yard. And if we want to know the value, total value of earnings, we do $30 times every yard he mows, right? His total value for a day is going to be $30 times every yard he mows. So how much value does he need in a day to earn at least means greater than or equal to $200. All right. Well, we know that our value is $30 times every yard, so we can just substitute that there. Greater than or equal to 200. And do division. We want to get y by itself divided by 30 divided by 30. All right. Now, something interesting happens. When we do this division, we're left with yards is greater than or equal to, these dollar signs cancel out, cancel, 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 cancel. So we actually have I think it's 6667. So he has to mow greater than 6.667 yards. Is he going to get paid if he doesn't mow a complete yard? No. So in that case, forgot the little equals part. In that case, we need to round up. So he needs to mow greater than or equal to 7 yards in order to earn at least $200. All right, I'll do one more. All right, we got a tricky one here, but it's not tricky if we take our time. A manufacturer sells golf balls at $7.20 per box. How many boxes of balls must be sold to make at least $9,116 profit if the expenses include materials, blank, labor, blank, and additional overhead, blank? All right, let's start with our knowns and our unknowns. Knowns. We know the materials. The cost of materials equals $3,275. We know our labor. It equals $8,430. We know our overhead. It equals $2,320. What else do we know? We know that a box of golf balls equals $7.20. Now, remember, we got to distinguish between the price and the quantity. So what's our subject for this question? How many boxes? Boxes are the subject. So we want to, so $7.20 isn't the amount of boxes, it's the price per box, which just means we make $7.20 for every box we sell equals the total, or total value. This is one way of saying it. All right, so this is where that $7.20 belongs. All right, now we have another value here, profit. So that's another known. Profit equals 9,116. And actually, it doesn't say profit equals. It says profit is at least. So what does at least mean? Greater than or equal to. So let's make sure we're keeping an eye out for these inequalities. All right, so we got a whole mess of things. All right, now it's all going to come down to profit. What is profit? Profit is the total amount you bring in minus the expenses. So total value, total income, minus expenses. Minus expenses. All right, so we just substituted our P here, and and greater than or equal to, still greater than or equal to 9,116. All right, great. Total income, that's our total income from selling boxes, which is just our total value. These two are one and the same right now, so we know what that's going to equal. That's going to equal $7.20 times $7.20 for every box sold. That's going to be our total income. And the expenses, what do you think our expenses are? It's everything else combined. So our expenses is, and remember, use parentheses for substitution because it comes into play exactly right here, especially when there's a negative sign. All our expenses are our materials plus our labor plus our overhead. All this has got to be greater than or equal to 9,116. Now let's we can drop the parentheses on this one, minus our materials is whatever it is, 3,275. Our labor is whatever it is, 8,430, I hope. Yep. And then our overhead is whatever it is. Great. Greater than or equal to 9. And what's the original question? How many boxes? So we want to solve for B. Solve means get B by itself, but let's simplify first. So nothing changes here, but we do got our parentheses. Parentheses first in order of operations. Add those up. What do we get? And I'm being a little slack with my units here, and our units in this case are dollars, but it's usually good to, it's important usually to keep them on, but anyway, adding all that up gives us 14,000 and some change. Right, what's happening to B? Being multiplied then subtracted, so we want to undo that subtraction with addition, adding the same thing back on both sides, 14,025. That's going to give us 720B is greater than or equal to 23,141, and finally to get the B by itself we divide by 720 or 7.20, and that's going to give us a weird number. I'll tell you exactly what. That's going to give us B is greater than or equal to 3. And this is why the units are important, because we're dividing by the dollar amount, which means the dollars are canceling. The units are canceling, so we're no longer dealing with dollars. We are dealing with just the amount of boxes. So this is going to give us 3,214.027. Now, just like the last problem we did, because it's greater than or equal to, we can't sell a partial box, so we do got to round up. Rounding up will give us the number of boxes sold needs to be greater than or equal to 3,215 boxes, and if we do that, we will make a profit of at least 9,116. Alright, that's all from this. The points are, write it down, take your time, knowns and unknowns, and whatever the rest of that chart was. Knowns and unknowns, figure out if we're using equal signs or inequalities, write it out in math terms, solve, which means to get the variable by itself, and go back to the original problem to see what we're answering for. Anyway, that's all. Bye.